I am Anil Kumar, and in this video we will understand the strategy which can be used to find instantaneous rate of change using difference quotient method. So we'll continue with the same question, which is as a large snowball melts, its size changes. The volume V in cubic centimeters is given by the equation V equals to 4 by 3 pi r cube, where r is the radius in centimeters and r belongs to the set of real numbers from 0 to 30. Determine the instantaneous rate of change of the volume when the radius is 10 centimeter using difference quotient method. So in previous two videos we have learned how to find average rate of change, and then we did instantaneous rate of change using preceding and following method, and now we'll use next method, which is difference quotient method. Now instantaneous rate of change using difference quotient method basically is f of a plus h minus f of a divided by h, right? Where a is the point of our interest. In this case it is radius of 10 centimeter. So whenever you do this method, at that time h is to be taken as very small. So normally you can take h as 0.01. Now here we can follow combination with the preceding and following method also. That is to say, calculate the value of the function at f of our point of interest a. In our case a equals to 10 centimeter, correct? So we can say 10 plus 0.01, find this value. That is to say v will be 4 over 3 pi 10.01 whole cube, right? F of, I could have also written v of this, right? So I'm using function f, right? So we could actually write volume v at 10, that is 4 by 3 pi 10 cube, right? And also volume when it is 0.01 less, that means 10 minus 0.01. So it'd be 4 by 3 pi 10 minus 0.19.99 cube, correct? Use your calculator to find these values, correct? So you could replace f with v, since we are talking about volume as a function of radius, correct? Now once you have calculated these values, then you find instantaneous rate of change by preceding and following method, and then you can take the average of two, right? So we could write here instantaneous rate of change, preceding method. Preceding will be including these two values before 10, right? So will be v of 10 minus v of 9.99 divided by 10 minus 9.99, which is 0.01. Similarly, calculate instantaneous rate of change for the following, which will be v of 10.01 minus v of 10 divided by 0.01. Once you have calculated these values, then you find average of the two to get the accurate answer, correct? So then you can say average instantaneous rate of change at 10 is equals to average of these two, that is instantaneous rate of change preceding plus instantaneous rate of change following, correct, divided by 2. So the average value will give you the instantaneous rate of change. I'm not calculating using the calculator, but I'm giving you the answer here. The answer will be 1256.6 approximately, right? Don't forget to write the units, which is centimeter cube over centimeter. Again and again I'm reminding you for units, since it is very important, right? Another method which we have to find instantaneous rate of change is the centered method, which I haven't done so far and for this example, where we actually take the value 0.01 to the left of 10 and 0.01 to the right of 10. That means if we follow the centered method, let me introduce here. If I do centered method combined with this difference quotient method, what I could have done here is we could have really found the value like this, that instantaneous rate of change at r equals to 10 will be equals to, we could use these two values, right? Since 10 is in the center of these two, perfect. So we could have said volume when it was 10.01 minus volume 9.99 divided by difference between these two, right, which is 0.02. That will also give you approximately the same answer. Perfect. So you could use centered method also. Now just to remind you, so we have actually a couple of methods to find instantaneous rate of change. One is preceding method, the other one is following method, then we have centered method and the difference quotient. There are a few examples where you can only apply one of these methods. For example, when you throw a ball, then there is nothing happening before throwing the ball. So in that case, preceding method cannot be used. Only following method will be used. When the ball hits the ground, at that time only preceding method can be used. The centered or following method cannot be used, right? Since when the ball hits the ground, the equation is no more valid. But in between, you could use all or any of these methods. So this is a quick reminder of how you should be solving questions related to rate of change. Thank you and all the best.